Alright guys, welcome back. So in this video, we're going to be solving question 30 from the second chapter of the Mechanics of Materials by Beer and Johnston. And we have a vertical load P that is applied at the center of the upper section of a homogeneous frustum of a circular cone that has a height of h, and the minimum radius is a, and the maximum radius is b. And we know it has the elastic modulus of E, and we can neglect the effect of the weight, and we need to determine the deflection of point A right here. So if I look at this frustum from here, I'm gonna draw what we see in 2D. So basically we're gonna have, if we just continue this to make the full cone, we're gonna see a right triangle in here where we have A in here, B in here, and we know this distance would be our h. And let's just put our origin in here and call this our y-axis. So the distance that we are here is going to be our y. And also let's call this distance here a1, and what we have from the top to the bottom b1. And basically I'm trying to, and let's just consider the radius r in here moving from A1 to B1 on our y-axis. So I'm gonna just call this angle right here theta, and if we want to find the tangent of theta, basically we're gonna have the opposite over adjacent. So we can show it also with this right triangle here. This angle will be also theta, and this side would be basically b minus a. So tangent of theta is b minus a, which is the opposite over this side, which is h. And we also know the tangent of theta in here can be written as a over a1 if we look at this right triangle here. And it can be also written as b over b1 if we look at this right triangle. So tangent of theta can be also written as b over b1. Or if we go with our y and r, or if I look, I'm just going to highlight this one in yellow. If we look at this right triangle here, again, our tangent of theta would be r over y. So basically we are moving from a1 to b1, which is our partial cone. So this can be written as this. So our y is basically r tangent of theta. So as we discussed in the previous question, we have the same formula for deformation. Delta is equal to P times the length over A times E. So our length in here would be Y. And if we do derivative of delta with respect to Y, derivative of delta would be P times dy over A times E. Our area would be basically the area where we move from A1 to B1. So basically our area is pi times r squared. So let's just put all of those in here. The delta is equal to P times dy over a p r squared. I made a mistake in the previous part. So here our r is equal to y times tangent of theta. So I'm just going to put that in here. So we have r squared, which is basically y tangent of theta to the power of 2, and we're going to have the elastic modulus. Now we can do our integral starting from a1 to b1, which is how we make our partial cone. So this is going to give us the deflection of point A. So delta A will be equal to P over, I'm going to bring all the constants on one side, pi times E times tangent squared of theta, and we're gonna have the integral of 1 over y squared dy from a1 to b1. So our deformation of point A would be basically, again, I'm going to take all the constants out, pi times E times tangent squared of theta, And we have integral of 1 over y squared with respect to y, which would be basically minus 1 over y, and this would be basically y to the power of minus 2. And for this, we're going to have, if we want to find the integral of this, we're going to have minus 2 plus 1 times y to the power of minus 2 plus 1. This is going to be minus 1, and this will be y to the power of minus 1, or what we have in here. So we are moving from A1 to B1 to make our cone. So this part would be the same, pi times E times tangent squared of theta, and we're going to have 1 minus 1 over B1 minus minus A1, so this will be plus. So we can simplify this part a little bit better. So basically we have 1 over A1 minus 1 over B1, 1 over B1. We're going to take the common denominator, which will be A1, B1, and in the numerator, we're going to have B1 minus A1. So what we're going to have at the end for our deformation of A is going to be P over pi times E times A1 tangent of theta times B1 tangent of theta, and we're going to have B1 minus A1. So basically, I brought these two in here and I separate them like this. And the reason I did that because A1 tangent of, if you look at this, A1 tangent of theta would be A, and a B1 tangent of theta would be B. So basically, this can be written as P times B1 minus A1 over pi times E times AB. And obviously the force P is going to compress our partial cone, so the deflection would be actually downward, and this would be the direction for our deflection, and the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.